In this problem, we have a fish swimming behind an oil tanker. It gets caught in the whirlpool created by its propellers. Fish has an angular speed of 1 radian per second. If the water in the whirlpool accelerates at a constant rate of 3 radians per second squared, what will the fish's instantaneous angular speed be 4.5 seconds later? The idea here is to really just look at, ignore almost the angular part, and just look at it as a linear motion problem. The speed is 1 in the beginning. It accelerates at 3, and it has a time of 4.5 seconds. I'll start by drawing a picture here. Here's the ship's propellers. And here's my fish that gets caught in this whirlpool and starts to rotate around. And so the big difference is that, again, I have my speed of 1 radian per second. Instead of v, I now write omegas. And I accelerate at 3 radians per second squared. Again, it's an acceleration, but now I use the Greek letter alpha. And then the time is 4.5 seconds. And that's still t for time. We want to find the fish's angular speed after, again, find the speed after 4.5 seconds. So if it helps, I mean, it's just velocity is 1, acceleration is 3, time is 4.5. What's the final velocity? It's no different than back when we first started to do linear motion. We go to our equations. Again, these equations are nothing new. We want to find the final velocity. So I see that final velocity is in 3 different equations here. Those are my choices. If we look at the first equation, I need to know everything else to know or to use that equation. So to use this first equation, this possibility, we need to know the initial angular speed, which is 1, the acceleration, which is 3, and the time, which is 4.5. So actually this equation is the one that we want to use. So we want to use the equation, final velocity is the initial velocity plus the acceleration time for time. Now we can put in our numbers, substitute our numbers. So we have 1 radian per second plus 3 radians per second squared times 4.5 seconds. And then we solve for our answer. And we get 14.5 radians per second. So problems really are no different. We solve them the same way as we did in the very beginning.